Hi, hello, good evening everyone. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep, and warm welcome to everyone to this GATE AIMER'S 2023 series. Join the session quickly and mark your presence, dear friends. Today we are going to discuss one important topic of computer networks, and frequently we get questions from this topic, that is efficiency or utilization in computer networks. Okay, so before I start, let me introduce myself quickly. I am Satya with 15 plus years of teaching experience, mentored more than 35,000 students all over India into GATE and PSU segments, and I am qualified in GATE, UGC NET, SET, and also certified by Cisco. This is quick brief about me. GATE AIMER'S series, which started on 14th November for electrical, electronics, instrumentation and computer science students, which is a free crash course where important subjects, important topics we are discussing along with some practice. So guys, it would be very useful series. Try to attend all the sessions regularly and get most the benefit out of it. And we have already started this PYQ series where last 5 years PYQs we would be solving live of every subject from on 18th December for electrical, electronics and instrumentation, and very soon we will start it for computer science also. So you can get the solutions of last 5 years PYQs live in this series. And now you can avail 90% scholarship up to by taking our scholarship test on all our preparation programs. You can get up to 90% scholarship, dear friends. So register for this scholarship test, which will happen on 24th December 8 p.m. Okay. Now to start with, when we need to talk about this efficiency and utilization, definitely we have to go through once the functionalities of data link layer. What are the functionalities? Data link layer is responsible for node to node delivery. Okay, node to node delivery, framing, error control, flow control, access control, physical addressing. In the last class, yesterday class, we have discussed error control related topic, that is CRC and Hamming code. This is what we have discussed yesterday. Today, let us pick this flow control topic because efficiency utilization is related to this topic. Flow control. What is this flow control? When there are two stations communicating with each other, if two stations are at different speeds, then the slow station should not overwhelm, right? When the sender is fast, let us say when the sender sends at a faster rate, if the receiver is unable to receive at that speed, then obviously data loss occur, multiple retransmissions necessity arise. So we have to implement some measures to regulate that amount of data sent by the sender so that receiver is able to receive without any data loss, right? So the measures that we take to regulate this data flow, those measures we are calling as flow control measures, flow control techniques. So flow control restricts the number of frames that the sender can send before it waits for an acknowledgement from the receiver. This flow control we can understand in two ways. One is feedback based flow control, other is rate based flow control. Feedback based flow control, this is what happens at data link layer. Rate based flow control, this is what happens at transport layer on the name of congestion control. Okay, these flow control protocols at the data link layer are classified for noiseless channels, for noisy channels. Noiseless channels are not suitable for communication, so leaving them. For noisy channels, we have three protocols: stop and wait ARQ, go back and ARQ, selective repeat ARQ. I am not discussing about these protocols in detail here because our topic is efficiency utilization. So, let us understand what is utilization. Utilization means it is the average traffic over particular channel expressed as percentage of total link capacity. That means when the total link capacity is 100% and how much you have accommodated, let's say 70% you have accommodated, 30% of the capacity, 50% of the capacity. So how much you have utilized, the bandwidth available, how much you have utilized in that. That is what we call as utilization. And what is the efficiency? These two terms are mostly interchangeable. Okay, this is the efficiency is less commonly used term, that is defined as the ratio of the time taken to transmit, okay, to the total time. Here the data transmitted over total capacity. Efficiency we are measuring time taken to transmit over total time. That means both are related. Utilization we are talking in terms of capacity, efficiency we are talking in terms of time. For example, if you take our GATE exam, GATE exam is for 100 marks. Let's say you have attempted 70 questions. 70 marks. 65 questions total you have attempted, let us say 50 questions. So 50 by 60 is what utilization. Or if I talk in terms of time or in terms of marks, let's say for 100 marks you have attempted for 70 marks. So both are talking about out of total how much you have attempted, but one is talking in terms of number of questions, other is talking in terms of number of marks, isn't it? So both are similar representations, both are similar analysis, but the parameter that we are using, that is different, isn't it? In the same way, utilization is talking about the capacity. Out of the existing capacity, how much you have utilized. Means you can send 100 megabits at a time, but you are sending only 20 megabits. So that is what utilization. Same I am telling now, listen carefully. I can send 100 megabits in 1 second. So the total time, let's say for sending one frame is 20 milliseconds. Total time means I have to transmit the frame, propagate the frame, transmit the acknowledgement, receive the acknowledgement. Then I can confirm that the frame is delivered, received by receiver successfully. So out of this total time, how much time you are spending for transmitting the frame? Got it? So utilization, efficiency are more or less similar analysis. Just the representations or the parameters used are different, but we can say both are of same. So how we find out this efficiency or utilization? Let us calculate what is the total time for one packet or one frame. Let us calculate what is the total time for one packet or one frame. What is the total time, guys? First, let A wants to send through this channel to B. Okay? So A has to load the data, the frame, the packet into the channel. This is taking transmission delay. And that packet has to travel towards B, propagation delay. Then once receiver accept or reject whatever may be the acknowledgement must be loaded into the channel. So acknowledgement transmission delay, and acknowledgement should be propagated. Acknowledgement propagation delay. Okay, this is frame transmission delay, frame propagation delay. This is acknowledgement transmission delay or acknowledgement propagation delay. How we calculate transmission delay? It is the packet size upon bandwidth. And how we calculate propagation delay? It is the length of the channel upon speed or distance by velocity, regular time calculation. In these two, if you observe, which time is varying, affecting based on the packet size? Transmission delay varies. Propagation delay is independent of packet size, isn't it? So propagation delay of the frame, propagation delay of the acknowledgement will be same. So let me take it as one propagation delay. Okay, just PD. PD1, PD2, both I am taking as PD. So what is the total time for one packet, neglecting the other delays, queuing delay, processing delay? If at all they need to be considered, we will add. So here I am neglecting queuing delay, processing delay. Okay. Then what would be the total time? The frame should be loaded into the channel, frame transmission delay plus frame propagation delay plus acknowledgement transmission delay plus acknowledgement propagation delay. So this is TD1 plus TD2 plus 2 times of propagation delay. So what is this 2 times of propagation delay? We call as round trip time, to journey, fro journey time, isn't it? Now, how I calculate frame transmission delay, frame size by bandwidth? Acknowledgement transmission delay, acknowledgement size by bandwidth. We know acknowledgement size is less than frame size. Obviously, acknowledgement size will be very less compared with frame size. Such acknowledgement size I am dividing with bandwidth number. So it would be very, very less, right? Right? It would be very, very less, because already it is a small number. That small number I am again dividing with some number, so it becomes even more small. That means acknowledgement transmission delay is becoming very minute or very less. So taking that into consideration, the total time T is 1 transmission delay plus 2 times of propagation delay, neglecting TD2. So this is what the total time. Okay. Now in this total time, the amount of data transferred, the amount of data transmitted in the total time, or unit time, you say, one packet time. This is what efficiency or utilization. How much you transmit without waiting for the acknowledgement, that depends on what flow control procedure we follow. But commonly we can say window amount of frames or window number of frames we can transmit in one frame time, right? So what is this window? This sender's window size W is equal to 1 for stop and wait, 2 raised to n minus 1 for go back n, 2 raised to n minus 1 for selective repeat or selective reject. So efficiency or utilization is equal to or you can say it can be less or equal to window number of frames you can transmit, and for every frame to transmit, transmission delay divided by total time. Just now we have calculated TD plus 2PD. So if I take TD common, so E or U less than or equal to W divided by 1 plus 2 into PD by TD. So efficiency or utilization is now W by 1 plus 2A, where A is equal to PD by TD. So if I substitute just some A for PD by TD, now it becomes W by 1 plus 2A, right? So this is what the efficiency or utilization formula. This is how we got. Okay. So before we proceed for the questions, now you can avail our test series where you can get unlimited access to full length mock tests and subject wise tests. So we are providing both, guys, full length mock tests and subject wise tests, where altogether you will be getting 4000 plus practice questions. Those 4000 include 40 plus full length mock tests and 30 plus subject wise tests. Every question is prepared with uttermost care by our All India rankers, and the platform will offer you virtual calculator so that you will get the actual feel of writing the GATE exam, and you will get detailed mock analysis also. So keep attempting these full length mock tests by taking our test series. Okay, so guys, those who are watching it, could you please let me know your presence in the chat box. Now you can download our free ebook and get the notifications about our scholarship tests on a regular basis, and also our workshops on a regular basis by subscribing to our BEP YouTube channel and by registering through the link given in the description box. Okay, so this is 2008 GATE question, guys. The question is like this: a 1 Mbps satellite link connects two ground stations. The altitude of the satellite is 36,504 km and speed of the signal is 3 multiplied by 10 power 8 meters per second. What should be the packet size for channel utilization of 25% for a satellite link using Go Back 127 sliding window protocol? Assume acknowledgement packets are negligible in size and there are no errors during communication. Okay, let us solve it. We are given bandwidth 1 Mbps, length, speed, utilization. Go back 127, that means W is equal to 127. We know U is less than or equal to W by 1 plus 2A. Okay, where A is equal to propagation delay by transmission delay. So let us calculate propagation delay, that is equal to 36,504 kilometers. I am directly converting into meters, divided by 3 multiplied by 10 power 8 meters per second. So meters gets cancelled, and 36,504 divided by 3, that is 12168 into 10 power minus 5 seconds. I may convert it as 121,680 microseconds. I may write, isn't it? So let it be. Now transmission delay is what? Packet size by bandwidth. Packet size is what I want to find out. Let it be X. Bandwidth is given as 1 megabit per second. So now what would be A? A is equal to PD 121,680 into 10 power minus 6 seconds divided by TD, packet size is X, by bandwidth means it goes to the numerator. So this is equal to 1 into 10 power 6 bits per second, isn't it? So 10 power 6, 10 power minus 6 per second, gone. So A is what? 121,680 bits by X. We don't know what is X. So now let us substitute this A in the utilization formula. Utilization is given as 25%. So 25 by 100 less than or equal to W given as 127 divided by 1 plus 2 into 121,680 by X. So if I cross multiply, This is 1 plus 2 into 121680 by x is equal to 4 into 127 508. Okay. So now when I want x, so x is equal to this one also, if it goes there, it becomes 507. So now it is 2 into 121680 divided by 507. So let us calculate it using calculator. 2 multiplied by 121680 divided by 507 is giving 480. So x is equal to 480 bits. We got in bits, no? But if I want in bytes, 480 by 8, 60 bytes. Hi, Arun Kumar. So answer is 60 bytes. Got it, everybody? Let's proceed to next question. Everybody please respond, make the session interactive, and keep liking the session, keep sharing. Here we got 2015 GATE question. Consider a network connected two systems located 8,000 kilometers apart. Bandwidth is given, propagation speed is given. Okay, these are all 500 into 10 power 6. Okay. And the average packet size is 10 power 7 bits. So bandwidth is given, speed is given, go back and protocol, average packet size is 10 power 7 bits, network to be used to its full capacity, that means utilization should be 100%, processing delays are negligible, then minimum size in bits of the sequence number field. What is sequence number field? W for go back n is 2 raised to small n minus 1. That small n is the sequence number. So we should find out small n. Okay? Let's do it. So these are the specifications. For go back and we know u must be less than or equal to w by 1 plus 2a, where a is propagation delay by transmission delay, w is 2 raised to n minus 1. So first calculate propagation delay, that is length by speed, 8,000 kilometers means into 10 cube meters by 4 into 10 power 6 meters per second. This results in 2, right? And a transmission delay, packet size by bandwidth, 10 power 7 bits divided by 500 into 10 power 6 bits per second. So 10 by 500, 1 by 50, this is 0.02 seconds. This also in seconds. Now what is A? 2 divided by 0.02 seconds. Okay, seconds gets cancelled, right? So it is just 2 by 0.02. I can say it is 100. Right? Now, u is given as 100%. So, 1 less than or equal to 2 power n minus 1 by 1 plus 2 into 100. So, that indicates 201 must be less than or equal to 2 power n minus 1. That means 2 power n must be greater than or equal to 202. So, you can say n is log 202 base 2, but here you can understand for what n value this will be satisfied. If you take n as 7, 128 greater than 202, no. So, definitely n should be 8 bits. So, the minimum number, it is satisfied for 9, 10, 11, any number greater than 8. We want the minimum value, so it is 8 bits. Got it? All right. Next question. 2014 GATE question is here. Consider a selective repeat sliding window protocol that uses frame size of 1 KB to send data on 1.5 Mbps link with one-way latency of 50 milliseconds. To achieve a link utilization of 60%, the minimum number of bits required to represent sequence number field. That means again we want what? Small n. Small n. Let's do it. Now it is selective repeat protocol. So we know u is less than or equal to w by 1 plus 2a. Here a is propagation delay by transmission delay. W is 2 raised to n minus 1. Isn't it? Now, propagation delay is directly given. Let us calculate a transmission delay. 1 kilobyte by 1.5 Mbps. So, this is, I can write 1 into 10 cube into 8 bits by 1.5 into 10 power 6 bits per second. So, here you will get 8 by 1.5 milliseconds. Let it be, no need to expand, no need to calculate, let it be. We want A. A is PD by TD. PD is 50 milliseconds by TD. 8 divided by 1.5. That means 1.5 goes here, no? So, this is 75 by 8. So, A value is 75 by 8. Now, substitute U 60 by 100 less than or equal to 2 power n minus 1 divided by 1 plus 2 into 75 by 8. Okay. So, 23s are 25s are. Now cross multiplication I am doing. 3 into 1 plus 75 by 4 less than or equal to 5 into 2 power n minus 1, or let it be here only because we ultimately want n. So, let it be 5 also be here. So, now it is 3 by 5 plus 3 into 75. 3 5s are 15, 3 7s are 21 plus 1 22 divided by 20 less than or equal to 2 power n minus 1. So, it is 60 plus 5 into 225, 1125 by 100. So 1125 plus 60 by 100. So you get finally 11.85. 11.85 must be less than or equal to 2 raised to n minus 1. If I take n as 4, it becomes 2 cube, right, because n minus 1. So 8 greater than 11.85? No. So n must be 5. Cinema, you are preparing for 2023 GATE exam. Now you want to subscribe. No problem. Please contact our customer care. They will help you out. Okay? Fine. So n value is 5. Okay? So this I am giving for your homework, guys. It's a 2016 GATE question. Please do it. That's all for today about utilization or efficiency in networks. This is my Telegram group link. If you have not joined yet, please do join to connect with me for guidance, PDFs, doubts, and also to interact with your student friends who are preparing for the GATE exam. Okay? Thank you so much for joining the session. I hope this session made this utilization or efficiency concept clear. See you in the next session, that is tomorrow. Tomorrow I will be discussing interesting topic, that is about DNS. About DNS I am going to discuss tomorrow sharp at 9 p.m. So join me sharp at 9 p.m. tomorrow. Till then, have a great time. Take care everyone. Good night. Bye-bye. Thank you.